Okay, so if you draw a picture, that picture is going to look like. Okay, is it still frozen? Hit freeze again. There we go. All right, we've got a mean of 60 and a standard deviation of 6. So we've got a 66 here, and we've got a 72 here, and we've got a 54 here, and a what? 48 here. Give the standard score and approximate percentage for a data value of 64.8. So I'm going to take my blue marker, 64.8. Well, let's think, 60 to 66. What's half of that? What's the midpoint? 63 would be in the middle right here. So 64, that's 65. So here's 64 right here, 65. I'd say it's probably right in here. That's my value right there. They want to know what the percentage is. Now, I don't know if it says right or left. I guess since it's not specifying right, I guess it's assuming the left-hand side. An approximate percentage for a data value of 64.8. So here's our 64.8. But our data values right here in the table do not reference 64.8, so we need to change it into a what? A z-score. So 64.8 minus 60 over standard deviation of 6. Now, before we even do the math, I want to ask you all a question. Here is red mark. Now, what is that red mark right here? What does that represent? The middle or center. And we know that in statistics, the center is everything. All right? What's to the right of center? Positive or negative values? Positive. What's to the left of the center? Negative. And we're talking about z-scores, not 60 and 60. Those are all positive numbers. But if you're talking about z-score, you got a 1 here and a what? A 2 there, and a negative 1 here, and a negative 2 there. Yes. Right? Because we're putting them all on a universal scale. So let me ask you a question. Is this going to be a positive z-score or a negative z-score? Good. So when you do your math, you know if you get a negative, you know you're doing something wrong. Because what students do here, some of the time they'll get a negative number and they'll go back and they'll erase the negative number and they'll go back and they'll switch these two numbers around so you'll get a what? Positive number, and that's wrong. You don't do that. If you get a negative number, that means it's a negative z-score. It's over here. If you get a positive number, it's over here. So don't change it just because you think you're supposed to get a positive number. So somebody give me the number they get right here. What is it?
0.8.
I'm sorry, what?
0.8.
0.8. Now look, we're almost to 1. So is that 0.8? Does that make sense? Yeah, because that's 1 right there. So, we quit. No, the standard z-score is 0.8. So you put 0.8 right here. And now they want to know what percentile. What percent represents the blue hatch marks right here? Well, you got to pull up your handy-dandy table. There's your handy-dandy table. Well, what's our z-score? So you find 0.8. Let me do this right quick. Find 0.8. Okay, here's Z-score. Here's negative, so that ain't going to be worth crap. So that's, and Z-score, those are all negative, so that ain't worth crap. So all that ain't worth crap. Hey, we got positives here. Ding, right here. Now, you need to make a note in your notes that whenever you are reading a Z-score percentile chart, it's most of the time it's from the what?
Left to right.
From the left. Your percentiles are from the left. So that means the left side, where those blue hatch marks are that I did a while ago, is 78.81%. Oops.
Do you always subtract the middle number?
Hold on a second. 71 point, what'd I say?
78.81.
78 point what? 81% represents this right here. The blue hatches right here. Up to that number. So it'd be 78.81. What did it say? Round to the nearest what? So what does 78.81 represent? 79th percentile. Now, what's your question?
Do you always subtract the middle number, like from you 64.8 minus 60?
Hold on. I'll give you that answer right here. The Z-score formula is X minus what? X bar over what?
Standard.
So what always goes here?
Okay. Okay.
So just make sure, do not start thinking. All right, because what happens is, this is what happens. Okay, I got a negative 0.8, negative 0.8, that ain't right, so I'm going to turn around and I'm going to switch it. And that's what y'all do. Y'all switch these two numbers just because you get a negative number. You don't do that. Whatever you get, make sure you plug in the numbers. X, right there. X bar, it's right there. And S, right here. 6. There's S. There's X bar. And there's X. So we type in those two numbers. This is a good question. So the first one was 0.8. And the second one is, what I say, 79. Next question. Consider the scatterplot. Scatterplot. Looks like this right here. Somebody tell me what that is. I'd say, yeah, negative what? And if you want to know how I get negative, which way do we read?
That's right.
Hold on, I can't draw with the mouse. And I'll tell you, just like I tell my algebra and calculus students, if we read from left to right, put your car right there. What's that car going to be doing? Going downhill. Downhill is a negative slope, negative correlation. Whatever you want to say, I would say
Strong.
2. That's what I would say. Yeah, whatever you say. Select the correct answer below. I don't even know what this is. It says, consider the scatterplot to the right. State whether the diagram is positive correlation. Summarize any conclusions.
Yeah,
Weight of cars. And this is city gas miles. So the higher the more weight of the car, the heavier the car, the what?
Worse.
The worse gas mileage or whatever. So which one's that?
generally get lower gas mileage.
Okay. All right, look at that one. Blow it up a little bit, Vanna, so everybody can see it, especially people that can't see that sit in the back of the room. Not saying that you're one of those people. Just saying. All right. So, most people that do this question don't have any, bring that down, Vanna, don't have any idea what to do first. Always remember, when you're dealing with standard deviation and mean, draw a picture. Draw the curve. Because that puts it in perspective. Go on down, Vanna. I think, no, wait a minute. So I'm just going to draw it because I have no idea how to do the question right now. I'm just reading it, and I'm just going to see if this helps me. All right, a length of pregnancy terms for a particular species of mammal are nearly normally distributed about a mean pregnancy length with a standard deviation of 9 days. About what percentage of births would be expected within 18 days? Okay, so they're not giving you a mean. So you just assume that this is 0. And what would this be right here? 9. And what would this be? What would this be? -9. And this would be what? -18. 18 days before. 18 days what? After. About blank percent of births would be expected to occur within 18 days of the mean pregnancy. Did I say 18 days after or 18 days before? Didn't. I said within. So that means 18 days before or what?
After.
Hey, then what is that? 2 standard deviations, which is what? Empirical rule. What's 2 standard deviations? Go to your empirical rule. What page was that on? 367? 387?
393.
I'm sorry, what? It's 387 through 393. I don't know why it took 3 pages when it only took Math 120 a half a page to explain, and I showed it to you. 90 what percent?
95.
95%. 95 is the answer I'm looking for. All right? If you put 95, if it has something funky in your book and you put it, I'll take that answer, he'll take it. This is a time when you would challenge it. If the answer comes out to be 96.3 or some weird number, whatever your book says, and you put 95 and get it wrong, then you come see me during office hours and I'll fix it. Won't I, Miss Wilson? If I like you, yeah. I don't do that for Miss Wilson, but I do it for y'all. Okay? Right, Miss Wilson? See? She's such a good student. 90, what did I say, 95? 95% is what I would put. Because the empirical rule says that 95% falls between what? 2 standard deviations. Even though they didn't give you the mean, they gave you the standard deviation, so you just assume this is the due date right here, and this is 9 days after, this is 18 days after, this is 18 days before, this is 9 days before. So we would put dang old 95. A computer randomly selects 1,000 names from a list of registered voters. Those selected are surveyed to predict who will win the election. 1,000. A computer randomly selects 1,000 names. Well, what would that be? Well, it's not systematic, because systematic is what? Every, fifth person, every sixth person? It's not a random sample. Why? Because a random sample, everybody has the same what? Now, you could say, well, everybody has the same chance because the computer, yeah, but it's picking not one name, but what? It's not convenience. Convenience would be hollering out the window or something like that. So what do you think it is? Stratified contains groups. Okay, next. Use the frequency table. For the ages of recent award-winning male actors at the time when they won the award to construct the corresponding histogram. There's your frequency distribution right there. They want you to build a histogram. Okay, it shouldn't be hard, people. You can actually take this over to Excel. Go to dang old. Right. Now, do I care whether you do a histogram or bar chart? Do I care? No, because they're the same thing. So if you have to, you can move them. I don't know if you can move them on here, but no, you probably can, but I'm not going to worry about it right now. I don't know if there's a histogram on here or not. Let's see. I don't see if they're touching. Let me get out of this. Try it again. Insert. What's that? No. I guess I'll just use. I don't know where the histogram is. Thought they had one, but you can do a bar chart. Nope. I'm just going to go with bar chart. There it is. So you got, looks kind of like a what? Normal distribution, doesn't it? Kind of. Could take some of that off and put right here, but that's what it looks like. So go back to your handy dandy question. Which ones look like? Looks like D, because these don't look like anything. When is week of finals? Sure? You sure it's got December 7th, 1941?
Okay, that's what it is.
Some people have put.
Is that Pearl Harbor? No, what? It is Pearl Harbor now.
Yeah. People put that. When does homework terminate?
Actually, not for you. You suck. If you can't read, how would you know that shoes I cannot read?
Exactly. All right, try this one. I'm going to let y'all do this one. Blow it up a little bit, Anna. Scores on the quantitative portion of exam have a blah, 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 blah. Assume the scores are normally distributed. What percentage of the students take the quantitative score above what? 600. Above. That means what side? Right-hand side or left-hand side?
Right.
Right-hand side. I told you that the right-hand side is 1 minus the what? Left-hand side, Hubert. That's right, class. watched the videos. You were here last week. Thanks for the interaction. That's why y'all gonna live in the ditch. That's why you're gonna drop the class, drop out of school, and live in the ditch. You already live in the ditch. You know DirecTV took that. That was my idea. Living in the ditch. That was my idea. So was Jason versus Freddy. That was my idea too. You know what I think they ought to have? The Predator versus Jason, Michael Myers, and you can throw Freddy in there too. I wonder if the Predator. Can you imagine the Predator going against Michael Myers or Jason? The Predator would be like scratching his head. The Predator would be like, "What the heck is this thing?" And Freddy, I don't think he could fathom Freddy.
You just can't fall asleep.
Yep.
So technically, it depends on if predator ever really sleeps.
Yeah.
Yeah, I've never seen him sleep. So.
But that's my idea. They have the Predator versus Jason.
Oh, here.
That's my idea. What is he talking about? Forget it. Don't worry about it. It's your parents'
Have you
fault.
seen you've seen the original Friday the 13th?
Oh, yeah, I've seen all of them.
I'm sorry, Nightmare on Elm Street.
I'm not as big a fan of Nightmare on Elm Street as I am of Jason. I like Jason and Michael.
Yeah.
I think Michael is more scary.
Yeah, this is the crazy one. He's not like dead.
Yeah. I like Rob Zombie's.
That House of Thousand Corpses.
I like Rob Zombie's Michael Myers better than the original Michael Myers. I like the way Rob Zombie explained his childhood better than the original Michael Myers. The original Michael Myers, they didn't explain it as good as Rob Zombie's did, in my opinion. All right, bring it down, Vanna, please. Hope this is helping y'all.
Help me.
Once you put that, as far as I understand,
Exactly.
Did you hit freeze, Vanna? What are you doing to me, Vanna? You didn't hit it? Okay, well, I'm just done screwed up. Yep.
There's a marker out there.
No, I don't like writing on the board. I can't write on the board very well. All right, so we get 569 is right here. Y'all want to come up here and write with a mouse? Anybody want to do it for me?
no, I'm good.
Come on up here if you think you can write better.
You got this.
All right, what's 569 plus 156?
725.
How much?
725.
725. And then what's 725 plus 156?
881.
Huh?
881.
881. It's irrelevant because ours is around 600. All right, do we have to do the left-hand side? No. Because what's our number that we're looking for?
600.
600. So 600, I'm just going to put it right in here. Put it in Quaker. There's 600 right there, somewhere in there. And we can only look up to what? The left-hand side with the table. Because that's what the table gives us. So let's go ahead and do our math. It'd be 600 minus what? 569, and I'll put it in blue because that's given. All this, well, X is minus 569 over
156.
156. And somebody give me that number.
0.20.
I'm sorry, what?
0.20.
0.20. So we pull up our handy dandy table. And we look up positive 0.2. And what do we get?
57.93.
Okay, 57.93 is the left-hand side. 57.93 is the left-hand side. I want the what? I want the right-hand side. So what do we got to get the right-hand side? Because it wants a score of more than 600. So to get to the right-hand side, it's 100 minus the what?
57.93.
All right, somebody give me that. Be 100, sorry. 100
42.
minus 57.93. And what do you get?
42.07.
42.07. And the directions say round to the nearest what? Whole number. So what's the nearest whole number?
42.
42. So 42% make a score of above what? 600. Next question. Frequency distribution. Do it. Oh, and they want a relative frequency and a cumulative frequency. Oh, this question's hard. I don't think y'all can do it. It's really difficult.
Being sarcastic.
Yeah.
Okay.
You think I would be sarcastic?
I don't know. I don't.
Well, we don't even have to put this on the spreadsheet. We just have to count. Because what is the frequency distribution? A hit count. 1, 2, 3, 4, 5. There's 5 A's. How many B's? 1, 2, 3, 4, 5, 6. I told you wouldn't be able to do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. D3. And how many people gonna live in a ditch? One. Let's add that up. 9 and 1 is 10. That's 6 and that's 19. 24. So 5 over 24 is, I'm sorry, what? 5 over 24, what is it?
1.21.
And that's 21. And what's 6 over 24? Huh? 25, or 0.25. And 9 over 24. One what?
375.
So that'd be 38. 3 over 24.
1.13.
13. And 1 over 24. I'm sorry, what?
0.04.
4. Somebody add those up. 3, 4, 5, 6, 7. Add them up, see what you get. What should they equal?
100.
100. I'm sorry, 100.
100.
101. I
100.
got 101.
Okay, then y'all done some rounding somewhere wrong. I'm not going to worry about it. Y'all can figure it out. No, in other words, take 5 divided by 24. Is it 21 or is it 20? Do that with each one.
Well, what's it say to round to? The nearest tenth.
Yeah.
So,
So what's 5 over 24?
0.208.
I'm sorry, what?
0.208.
0.208. So that would be 21.
okay.
All right. What's 6 divided by 24?
0.25.
Is it 0.25 Right on it?
Yeah, it's money.
Okay. 9 divided by 24.
0.375.
375 would be 38. 3 divided by 24.
0.125.
125. So it must be the 1 over 24.
0.041.
There, 041. I don't know. It should be equal to 100. We'll see when we answer. All right, what's the first one? 5. Then what? 11. Then what? 11. Then what? 20. And 23. I'm glad y'all are doing it because I can't keep up with it. 24. And what's the total? 24. How is homework, test, and exam weighed? The most missed question of the 10 questions that I give you, this one's the most missed. Why? What do people pick?
30.
And why is that wrong?
Because it's 26 to 20.
Well,
Adds up to 90%.
it adds up to 30%. I'm supposed to have a heart attack.
Sorry.
That's all right. Yeah, people pick C. And the reason C is not correct is C does not equal what? Yeah, some people that should be procreating. All right, what is a standard score? How do you find standard score quality? Standard score is a score of numbered standard deviations of data above or below the mean. A standard score is a data value equal to the mean. Well, you know that's not right. Standard score is the distance between data value and the nearest outlier. With the standard, I believe it's kind of this one. The standard score is the number of standard deviations a data line value lies above or below the mean. That's what I would say. You know it's not B or C. Standard score is a data value that lies within one standard deviation. Well, a standard score goes up to 2 standard deviations. Z-score goes 2 standard deviations to the left, 2 to the right, or 2 to the left, 2 to the right. So this says within 1, so I think it's C. I'm sorry.
You said A.
A, thank you. Choose the correct formula for the standard. Well, you know the standard deviation is where? On the bottom. So let's see if all of them say standard deviation on the bottom. Yep, yep,
No.
yep. That one don't. So you know it's not what? You know it's not D.
Or C.
'cause-
Or C.
Oh, I didn't see that. Sorry. So it's got to be one of these two. Which one is it?
B.
B, as in Bravo. I actually had somebody say, when I said Bravo 2 or 3 times because it was B, Bravo, and they said, why can't you just say good job?